Okay, today we're going to use the definition of modulus to solve this question 9 of the HSC. And I'll rewrite that. Question 9 of the HSC 2020 says find the maximum value of EI theta minus 2 plus EI theta plus 2. Now, if you want to do this using algebra, it's quite hard. But if you use the definition of modulus, it's quite easy. First of all, if you let z equals EI theta, you notice that that's 1. So that means that the modulus of z is the same as the modulus of z, which is basically 1. So that means that if you let that equals to z, then whatever z is, it lies on the unit circle, first of all. Now, in one of my other videos, this represents the length of the vector from 2 to z, this being z this time. So if you look at the diagram, z lies on this circle here. You start at 2, so where's 2? 2 is over here. What is the maximum length of that vector from 2 to z? Well, have a look at the circle. One of the known facts is that the longest length from outside a circle to any point in the circle is the length that passes through the center. That is something that a lot of people don't know, right? But a lot of people do know as well. So any point outside the circle, the maximum length of that goes through the center of the circle to the other side. So the maximum length in this case, if I put A, B, C, D, the maximum length is AD. That's the maximum length. So in this case, the center is here. The maximum length goes from 2 to this point here. So the maximum length of this, so the maximum length of this guy is 3 in this case, because that's 2 and then plus 1 is 3. By the same token, what is EI theta plus 2? Well, you have to change that to make it Z minus Z1. So it'll be minus minus 2. So again, this represents the length of the vector from minus 2 this time to Z. So again, where is minus 2? Minus 2 is on this side. So again, what is the maximum length from this to the circle? Well, the center is here. The maximum length, as you can see, is that length there, which is 3. So the maximum length of this guy is 3. So when you put the two together, does that mean the maximum length is 6? No. Z, right, the same point. The same point on the circle. So if you draw the circle here, again, you have to pick a point such that the length of both EI theta minus 2 and EI theta plus 2, you can only pick one. So let's say you pick this one as your Z. Then the length of the vector from minus 2 to Z would be that one, which is 3. And the length of the vector from 2 to Z will be that one, so there'd be only 1. And 3 plus 1 is 4. Is that the maximum length of the two added together? Well, the answer is no. Sam, if you pick this point as well, the length of the vector from here to here is 3, and the length of the vector from there to there is 1. So 3 plus 1 is 4. But if you look at the diagram, the answer is either here, where the Z is, or here, where you get the maximum length, because that length plus that length there together is longer than this whole length here, because this is Pythagoras of this triangle, and that's Pythagoras of this, and of course that length is bigger than this whole length over here. And this length is no secret, is 1, that's minus 2. So by Pythagoras, that's root 5. That's 2 squared plus 1 squared. The same there is root 5 as well. The same if you pick this point down here as well. So the maximum value is in fact root 5 plus root 5. So that's why the answer is 2 root 5 in that question. And that's why the answer is C. Let me put it back on for you to see. That's why the answer is C, 2 root 5. It's not 4. See, and that's the answer to that question of 2020 HSC, question number 9, and that's where I stop.